What if you could talk to someone on the other side of the planet without touching the internet, just using the pure, simple magic of radio waves? Well, that's what amateur or ham radio is all about. In this explainer, we're going to walk you through the very first step of that adventure, getting your official license right here in India based on the actual syllabus.
So here's our game plan. First, we'll talk about what this license is and why you need it. Then, we're going to peek under the hood at the basic radio theory and the key parts that make it all work. After that, we'll get into the rules of the road, learn a little bit of the lingo, and then map out your final steps to finally getting on the air.
So why even get a ham radio license? Look, it's way more than just a piece of paper. Think of it as your passport, your key to a global club of builders, scientists, emergency responders, and honestly, just friends you haven't had the chance to meet yet.
This picture right here shows the two incredible ways radio works. Your signal can travel as a ground wave, kind of hugging the curve of the earth to reach someone across town. Or, and this is the really cool part, it can shoot up as a sky wave, do an incredible bank shot off a layer in our atmosphere, and come down on a totally different continent. That's how you talk to the whole world, right from your own room.
The path to getting that license is one single test, but it's broken down into two main chunks. Section A is all about the science, the radio theory in practice, basically how the stuff works. Section B is all about the rules, the radio regulations you've got to know to be a good operator out there.
Okay, let's dive into Section A. And hey, don't worry, you don't need a PhD in physics for this. You just need to get your head around a few key ideas that make all of this radio communication possible in the first place.
It all starts here, at the tiniest level imaginable, with the atom. You've got your core, the nucleus, and these little negative things called electrons zipping around it. Literally, the entire science of radio is just about figuring out how to get these electrons to move where we want them to. That movement is electricity. And this is the fundamental difference that makes all electronics work. You've got conductors, like copper wire, where electrons can just flow freely, like water in a pipe. And then you have insulators, like the plastic coating on that wire, where the electrons are locked down tight. One lets the signal go, the other keeps it from going where you don't want it to. You absolutely need both. All right, now let's look at the actual parts you'll need to know. Think of these as the Lego bricks you'd use to build any radio transmitter or receiver. These are the nuts and bolts.
First up, the resistor. Its job is super simple. It's like a speed bump for electricity. Its entire purpose is to slow down, or resist, the flow of current. And we measure that resistance in a unit we call ohms. So how do you know how much speed bump you're getting from one of these? Well, you don't need a magnifying glass or anything. The component literally tells you what it is. These colored bands are a secret code that tells you everything you need to know. And this chart is our decoder ring. Come on, let's do one together. Say you have a resistor that's orange, orange, brown. Okay, we look at the chart. First band, orange, is a 3. Second band, orange, is another 3, so we've got 33. The third band, brown, is the multiplier. The chart says that's times 10, which just means add 1 0. So 33 with a 0 is 330 ohms. See? It's that easy once you know the code. Now this is where things get really, really clever. We take a material like silicon, which is a semiconductor, and we add tiny, specific impurities to it. It's a process called doping. This lets us create two new kinds of materials, N-type, which has extra electrons to give away, and P-type, which has empty holes that are looking for electrons. So what happens when you press these two types of materials together? Something amazing. Right at the junction, the extra electrons from the N side jump over to fill the empty holes on the P side. This creates a little barrier in the middle, and that barrier acts like a perfect one-way street for electricity. Current can flow one way, but it's totally blocked from going the other. We call this a diode. So, if a diode is a one-way street, then a transistor? Well, a transistor is like a high-tech faucet. You can make a little sandwich of these materials like NPN, and then use a tiny electrical signal on that middle layer to control a much, much bigger flow of electricity through the whole thing. This means you can switch a signal on or you can amplify it. And that amplification is the key to hearing a tiny radio signal from thousands of miles away.
Okay, so we've got the tech to send signals around the world. But, we're all sharing the same airwaves, so we need some rules of the road. And that brings us to Section B, the regulations and how to be a responsible operator in this big global community.
In India, one of the biggest differences between the license types is how much power you're allowed to transmit. With the restricted grade, you're limited to 50 watts on the high frequency or HF bands. Those are the ones for long distance chats. But if you get the general grade license, you can go all the way up to 400 watts. Once you pass that exam, you'll get something really special, a call sign. This is your unique identity on the air. It's how everyone will know who you are. The first part of it, the prefix, tells everyone what country you're in. For India, that prefix is VU.
A huge part of the regulations is about protecting the spirit of the hobby. The amateur radio bands are for personal, non-commercial fun and experimentation. That's why you can't play music, advertise your business, or get into big political debates. It's all about keeping it a space for technical learning and friendly chats.
Now, to make sure communication is fast and crystal clear, even when a signal is really weak and noisy, operators all over the world use a special shared language. It's a set of codes and alphabets that everyone, everywhere understands. At the heart of this are the Q codes. These are three-letter codes that are basically a universal shorthand. So instead of taking the time to ask, "What is your current location?" you can just say QTH. And if you want to say, "Yep, I got your message," you just say QSL. It's fast and efficient. And to make absolutely sure that names and call signs are understood perfectly, even through a bunch of static, operators use the International Phonetic Alphabet. So a call sign like VU2ABC wouldn't just be VU2ABC, it would be Victor Uniform 2 Alpha Bravo Charlie. It removes all doubt.
And just like that, you have your map. We've covered the basic science in Section A and the all-important rules of the road in Section B. This is the foundation, the stuff you need to know to pass that amateur station operator's certificate exam.
And remember, this is an official process. It's all managed by the Wireless Planning and Coordination Wing, or WPC, which is part of the Ministry of Communications. Passing their exam is your official gateway into this amazing global hobby. You've got the roadmap all the way from a single electron up to the rules of the airwaves. You know the language from Q codes to phonetics. There is a worldwide community connected by nothing but the magic of radio, just waiting to hear from you. So, are you ready to key up the mic?